All right, Algebra 1. Oh, which side am I going to come from? Left or right? Oh, hope you guessed right. Okay. Dividing radicals. Really, really in-depth process because first you have to know when to divide the radical, and then you need to know if you need to simplify it once you've divided it and multiplied it. Whew. Okay, so I got a couple examples for you here. Basically, there's one major rule when you are dividing radicals. We can never, ever have a radical sign left in the denominator. That doesn't work, but we're going to get there in a second. So, example 1 here, dividing radicals. So root 9 divided by root 25 is actually the same thing as me saying the square root of 9 over 25. So you're primarily going to see it like this, but just be aware that that can also happen. Okay. Now, this example is not that bad, actually, because you know what the square root of 9 is and you know what the square root of 25 is. This is actually just going to end up being 3 over 5. Okay, that's simple, that's easy. Just make sure you are aware if you can divide it or you can take the square root, do it. Leave it as a fraction because 3 doesn't go into 5 nicely, so just leave it as that. All right. This is where it gets kind of messy, and I wish you could totally see that on the bottom. I have to rewrite it. Okay. Example 2. We can never have a square root sign left in the denominator, ever. So we have to do something called rationalize the denominator. Basically what that means is you are going to multiply this fraction by that number, numerator times denominator. I'm going to show you how this is done. I wish you could see it. Hopefully you kind of can make out. No, you can't. All right. So basically this is what I need to do. Because I have this mess underneath here, I am going to multiply this fraction by a new fraction. And that new fraction is going to be basically whatever that denominator was, numerator over denominator. The reason we do that is because when you multiply a root sign by the same number underneath another root sign, it cancels and it's just left with the number underneath. And we've done a few like that. So basically here's what's going to end up being. It's going to be the square root of 75, which you probably already could have realized that. And this is going to be the square root of 9, which we can just represent as this. Well, I'll do that. So I know what these are, though. I can simplify this, and I'm going to be left with 5 root 3. And this is just 3. That ends up being my answer, 5 root 3 over 3. Okay? Rationalizing the denominator is this. That's rationalizing. That's rationalizing. This is rationalizing the denominator. Okay? Let's do a couple more examples. Go ahead and pause me and try the next ones on your own if you want. It will help you because we're going to do a lot of this. Okay. Example 3. Root 5 over root 7. These are not nice numbers, irrational, right? So I'm going to have to rationalize the denominator. So I'm going to multiply this fraction by a new fraction, and that new fraction is going to be root 7 over root 7. Okay? And that's going to give me the square root of 35 over the square root of 49, and I'm just going to play it the long way for now. So the square root of 35, can I pull any perfect squares out of that? Nope. Okay, so I'm going to leave that as the square root of 35 for now. When I get this here, this is just 7. I'm cool with that. Now, you can't divide those. You can't. Let's not divide those. Let's just leave them. Okay? So, final answer. Remember, this is rationalizing. That's rationalizing. That's rationalizing. That's rationalizing. Okay, last one here. 9 over root 3. Can't have it. Can't have it. So I'm going to go root 3 over root 3. Rationalizing the denominator. Now I'm left with 9 root 3, which I can't do anything with because root 3 is irrational. And then this is just going to be 3. Now, here's something interesting. I can actually simplify this even more because 9 divided by 3 is, 3. So when I end up here is, this is just going to be 3 root 3. Okay, okay. Check your work before you wreck your work. No, it doesn't work. Okay. Check it. We're going to do more in class. See ya.